Okay, iterative statements. Iterative. Iterative statements. Iterative statements, commonly called loops, provide for repeated execution until a condition is true. The while and for statements test the condition before executing the body. The do while executes the body and then tests its condition. The while statement. A while statement repeatedly executes a target statement as long as the condition is true. Okay. So in a while statement, which is often a block, is executed as long as the condition evaluates as true. Condition may not be empty. If the first evaluation of condition yields false, condition is not executed. The condition can be an expression or an initialized variable declaration. Ordinarily, the condition itself or the loop body must do something to change the value of the expression. Otherwise, the loop might never terminate. Okay. So variable defined in a while condition or while body are created and destroyed on each iteration. See, this is important. Okay. Using a while loop. A while loop is generally used when we want to iterate indefinitely, such as when we read input. So a while loop is also useful when we want access to the value of the loop control variable after the loop finishes. Okay. For example, here we have variable I, read until end of file. Then we can find the first negative element. So we got that. We can simply go here while, and then we can check while. Okay. So while is not end and first, and while value is greater than 0. Okay. We know that all elements in V are greater than or equal to 0. Okay. Okay. Check this. The first loop reads data from the standard input. We have no idea how many times this loop will execute. The condition fails when Cin reads invalid data, encounters some other input failure, or hits end of file. The second loop continues until we find a negative value. Right here. When the loop terminates, begin is either equal to v dot end, or it denotes an element in V whose value is less than 0. We can use the state of begin outside the while to determine outside the while to determine further processing. Okay, so write a program to read strings from the standard input looking for duplicate words. To read strings looking, the program should find places in the input where one word is followed immediately by itself. Okay, where places where one word is followed immediately by itself. Keep track of the largest number of times a single repetition occurs and which word is repeated. Print the maximum number of duplicates, or else print a message saying that no word was repeated. For example, if the input is this, how now, brown cow, the output should indicate that the word now occurred 3 times. Okay, we can do that. So exercise section, this is section 5.4.1. And this is 5.14. 5.14. Oh, stdio, my man. Okay, so Okay, so I need a way. Okay, the program should find places in the input where one word is followed. Okay, write a program to read strings from standard input looking for duplicated words. Okay. The program should find places in the input where one word is followed immediately by itself. Okay, so we'll store this. Then we have to check. Okay, so first I will create a vector. Bishop. Okay, so I would need a vector. I would need a string. So we will create a vector of string, right? And vec, and then we will read. Let's create let's create a string called temp. We will read into temp, right? Then we want to go through the vector, right? Okay, so while right, so I have to auto begin equals svec dot begin and end equals svec dot end. They both are of the same type. So again, while begin is not equals to end, right? Then we start a block. So we want to search duplicates, right? Write a program. The program should find places in the input where one word. Okay, write a program to read strings. Okay, so we are not actually reading strings. Sorry, we don't have to store the strings. Okay, so that is one thing. We don't have to store the strings. Okay, so the program should find places in the input where one word is followed immediately by itself. Okay, keep track of the largest number of times a single repetition occurs. Okay, so we can have let's say string in and string, let's say current, and then I max count equals 0. Okay, so I'll read the string temp, then we'll check if current. Okay, max count is okay, if current, if n equals current, right, then we can go max count plus plus, right? Dual would be okay, else we reset. Okay, else I would say current equals n and max count equals 0. Okay. So 0. uh, I think I should start it with 1, right? Because initially the count is 1. 1, okay. Initially a string will appear at least once, right? So okay, then keep track of the largest number of times a single repetition occurs and which word is repeated. Okay, so which word is repeated? I have, okay, so which word is repeated? So n equals current max count. Huh. Okay, I also have to make sure that max count and current count. Okay, so keep track of the largest number of times a single repetition occurs. Okay, write a program to read strings from centered input looking for duplicated words. The program should find places in the input. Okay, so I think I will need a vector of string, right? So svac. Okay, else we go svac dot pushback n, right? Okay, so I'm storing them here. I'm only input. Okay, I think I should first yeah, because max count I can find. Right, okay, so we will store the string first. Right, dot pushback and okay, there we go. Storing strings, storing the input first. Okay. The program should find places in the input where one word is followed immediately by itself. Okay, so current okay, so they should follow each other, right? Okay, so we'll go auto swig dot begin, and we are not, we should be const, since we are not changing anything, and then we'll go with while begin is not equals to end, input not updating anything. Okay, so storing, then okay, then we can say right, we can keep on reading. Now we can keep on reading. We'll say if right, zero. Okay, max count is 0. So we'll go with while begin is not equals to end, and we'll begin plus plus. So I can check if current equals to begin, current is equals to current, right? But I don't know what current is currently. Okay, I think I will be looking ahead. Do I want to look ahead? I would rather not. So stores the first element. Okay, then if current equals to, then we'll go max count plus plus. Okay, else right, if we do not match, okay, so if they are not equal, right, dude, this is proving okay. Keep track of the largest number of times a single repetition occurs and which word is repeated. Okay, the program should find places in the input where one word is followed immediately by itself. Okay, so I think I have done this kind of problem. This, right? One word is immediately followed by itself, Okay, we'll have a max count and then we have a current count. Okay. So we'll go current count plus plus. Right, okay, so current count plus plus. So then we'll go if current count is greater than max count, then we set max count equals to current count okay, and where is the updation? Okay, current count. Okay, so this checks if current and begin are equal. Right, if they are, then we increment its count. Then if current count is greater than max count, then we the max count. But count whose count? Okay, so then we say if current, alright, so okay, so if they are not equal, then current, ooh, but this is this would have been incremented by then, so my value would be wrong. So I would increment it in the beginning. Okay. Plus my logic was wrong. I was incrementing the strings, not that. Right. Okay. So current equals begin. Value of begin. Sorry. And then we can reset the current count equals 0. Current count is greater than max count, okay, but which string has that is so string max and max equals current. Okay, so we'll start with okay, if string matches increment count, right, else update the okay, if string matches increment count, else update the current string. I think yeah, no, it's okay. So else update the current string, and its count is currently 0. Okay, then we check if the current string has the highest count. What's the highest count? Okay, so I have a but why would it? That is not plus plus, right? Begin not equals to end. Then we can finally display the value. No, it was not just about the current one. Okay, so Yeah, okay. Then we have to write the word maths appeared appeared times. Okay, so let's feed it the value. Where is the value? There we go. Oh, sorry, yeah. Okay, first I have to compile it. My bad. Should I push in on the push in? It is a string, and I have okay. My bad. Operator plus plus. Okay, begin a const. Okay, passing const as this argument. Okay, so const expression. Okay. Oh yeah. Okay, but then I would have to use my bad. It has to go into the input stream. Can't it take it? Give me the command prompt. System cannot find the specified file. Oh, because yeah. Well, I have to manually give it. Exe. System cannot find. How did the input stream worked? I think it worked like this, right? No? Hold up. Variable basics sizes. Any notes regarding directives? Think directives. Nope. While output, yeah, input. Okay. Okay, now input output IO stream. Yeah. Okay. I think there should be a value reading a no number of inputs. Okay, we can also read, yeah, file redirection. Okay, so it says input dot txt and output dot txt. Okay, so I have to give it these values. Alright, got it. So it has to come. Alright, so go input.txt. Sub input .txt input.txt. Yep. A.txt input.txt. The word now appears two times. Well, the word now appeared 3 times, so I don't know where I went wrong. Okay, so current count plus plus. Oh yeah, okay. Current count is 1. The word has appeared date. Okay. Okay, so the word has appeared, so its count is 1. Okay, now this still I have to recompile it. Will it remember? No. Okay, 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 okay. G++ 5 CPP A and input a txt. Alright, my man, as you wish. Okay, great. Okay. Yeah, I know. Okay, done. Alright. Okay, traditional for statements. The syntactic form of the for statement is for initialization condition there should be a expression. So the for part inside the parenthesis is often referred to as the for header. Alright. Init statement must be a declaration statement, an expression statement, or a null statement. Okay. Each of the following statements ends with a semicolon, so the syntactic form can also be thought of as this. Okay. In general, init statement is used to initialize or assign a starting value that is modified over the course of the loop. In general, init statement is used to initialize or assign a starting value that is modified over the course of the loop. Condition serves as the loop control. Okay, loop control. And as long as the condition evaluates true, statement is executed. If the first evaluation of the condition yields false, statement is not executed. Expression usually modifies the variables initialized in init statement. Okay, expression usually modifies the variables initialized in init statements and tested in condition. Okay. Okay. Expression is evaluated after each iteration of the loop. Okay, expression is evaluated after each iteration of the loop. As usual, statements can be either a single or compound statement. Okay, so this is important, that expression is evaluated after each iteration of the loop. The expression. Which expression? This expression. So it goes this, then body, then okay. Execution flow in a traditional for loop. Okay, given the for loop from page this, process characters in S until we run out of characters or we hit a white space. Okay, capitalize the current characters. Okay, the order of evaluation is as follows. Init statement is executed once at the start of the loop. In this example, index is defined and initialized to 0. Okay, there we have it. Next, condition is evaluated. If the index is not equal to s dot size and the character at s index is not a white space, the for body is executed. Otherwise, for loop terminates. If the condition is false on the first iteration, then the for body is not executed at all. If the condition is true, the for body executes. In this case, the for body makes a character at s index uppercase. Like 2 upper. Okay. Finally, expression is evaluated. In this example, index is incremented by 1. These four steps represent these four steps represent the first iteration of the for loop. Step 1 is executed only once on entry to the loop. Step 2, 3, 4 are repeated until the condition evaluates as false. That is when we encounter false. That is when we encounter a white space character in S or index is greater than S dot size. It is worth remembering that it is worth remembering that the visibility of any object defined within the for header is limited to the body of the for loop. Thus, in the example, index is inaccessible after the for completes. Multiple definitions in the for loop. For header. As in any other declaration, init statement can define several objects. However, init statement may be only a single declaration statement. Therefore, as in any other declaration, init statement can define several objects. However, initialization statement may be only a single declaration statement. Therefore, all the variables must have the same base type. As for an example, we might write a loop to duplicate the elements of a vector on the end as follows. Okay, so we have I and then we have a size. This I not size. Okay. I plus plus we dot push. We have I. Okay. In the loop, we define both index I and the loop control variable size in init statement. Okay. This was actually useful. Okay. So omitting parts of the for header. A for header can omit any or all of init statement condition or expression. We can use a null statement. For init statement when an initialization is unnecessary. Okay. For example, we might rewrite the loop that looked for the first negative number in a vector so that it uses a for. Okay, so no work to do. Okay. Note that the semicolon is necessary to indicate the absence of init statement. More precisely, semicolon represents a null init statement. In this loop, the for body is also empty because all the work of the loop is done inside the for condition and expression. The condition decides when it's time to stop looking and the expression increments the iterator. Omitting condition is equivalent to writing true as a condition. Because the condition always evaluates as true, the for body must contain a statement that exits the loop. Otherwise, the loop will execute indefinitely. We can also omit expression. We can also omit expression from the for. What is for? We can also omit expression from the for header. In such loops, either the condition or the body must do something to advance the iteration. As an example, we'll rewrite the while loop that read input into a vector of ints. Alright. So we have okay, I got it. What was my mistake? I have to begin that there was a const begin and const add. I think it should be iterators. Yes, iterators. begin, and there were C begin, yes. Okay, I meant to write C begin and C end. C begin, C end. Okay, then make it again. Okay, this time it will work. Yeah, there. It was not const because const would not be able to increment it. Okay, C++ for you guys. Okay, so we can also omit expression from the for header. In such expression, okay, in such loops, either the condition or the body must do something to advance the iteration. So condition checks. Okay. So in this loop there is no need for an expression because the condition changes the value of I. The condition tests the input stream so that the loop ends when we've read when we've read all the input or encounter an input error. Range for statement. The new standard introduced a simpler for statement that can be used to iterate through the elements of a container or other sequence. The syntactic form of the range for is this. Expression must represent a sequence such as a braced initializer list, array, or an object of a type such as vector string that has begin in members that returns iterators. Okay. Declaration define the variable. Right. It must be possible to convert each element of the sequence to the variable's type. The easiest way to ensure that type matches is to use the auto specifier. Okay, that way the compiler will reduce the types for us. If we want to write to the elements in the sequence, the loop variable must be a reference type. Okay. On each, okay, right. So we have some exercise. Okay, I'll just quickly finish. On each iteration, the control variable is defined and initialized by the next value in the sequence, after which statement is executed. Okay. On each iteration, the control variable is defined and initialized by the next value in the sequence, after which statement is executed. As usual, statement can be a single statement or a block. Execution ends once all the elements have been processed. Okay. We have already seen several such loops, but for completeness, here is one that doubles the value of each element in the vector. Okay. The for header declares the loop control variable R and associates it with V. We use auto to let the compiler infer the correct type for R because we want to change the value of the elements in V. We declare R as a reference. When we assign to R inside the loop, that assignment changes the element to which R is bound. A range for is defined in terms of the equivalent traditional for. Okay. A range for is defined in terms of the equivalent traditional for. Okay. Here. Or to R. Giving a reference. Okay. Now that we know how a range for works, we can understand why we said in here that we cannot use a range for to add elements to the vector or other container. In a range for, the value of the end is cached. If we add elements, okay, now that we know how a range for works, we can understand why we said that we cannot use a range for to add elements in a vector other container. In a range for, the value of end is cached. If we add elements or remove them from the sequence, the value of the end might be invalidated, and we'll have more to say about that matter here. Okay, on to the exercises. Okay, explain each of the following loops. Correct any problems you detect. Okay. So what are we doing? Int ix equals to 0. Okay, can't refer to ix outside the for. Okay. Then we have int ix not equals to size, ix plus plus. Okay. There must be a initialization init statement in for. Okay, is equals to 0, size plus plus. Ooh. Okay, leads to infinite loop, since ix will never be equal to size. So we are repeatedly updating it, incrementing both. The while loop is particularly good at executing while some condition holds. For example, when we need to read values until the end of file. The for loop is generally thought of as a step loop. An index steps through a range of values in a collection. Write an idiomatic use of each loop and then rewrite each using other loop construct. Idiomatic. What do you mean? Okay, an index steps through a range of values in the collection. Write an idiomatic use of each loop and rewrite each using the other loop construct. If you could only use one loop, which loop would you use? Okay. For loop is better overall. Okay, done. Okay. Given two vectors of ints, write a program to determine whether one vector is a prefix of other. Whether one vector is a prefix of other. Okay. For vectors of unequal length, compare the number of elements of the smaller vector. For example, given the vectors containing 0, 1, 1, 1 and 2, 0 respectively, your program should return given two vectors of ints, write a program to determine whether one vector is a prefix of another. Okay. For vectors of unequal length, compare the number of elements of the smaller vector. Okay, prefix. Okay. If the values are, all the values in this vector should be less than all the values in this vector. Okay, got it. I can quickly write, this is section 5.4.2. We go here, statements, exercises, this is section 5.4.2. This is exercise 5.17. Nothing, right? Okay. So create an exercise. Okay, sorry, my bad. I want this exercise 5.17. 5.5.17.cpp. Okay. Alright, then we have, let's take two vectors. Okay. So we have vector of int, let's say v1, and then we have a vector of int vector of int, that is v2. I should, well, both are equivalent, so anyone can be. Okay, so we take 0 1 1 2 0 1 1 2, copy this, and we have 3 5 8, 3 5 8. Okay, first we'll check, let's check the length. Okay, you can say size, go integral type, integral type, that will be v1 dot size equals 0. Then if v1 dot size less than v2 dot size less than v2 dot size, let me set size equals v1 dot size, else yes, this size equals this, then we can go for okay, so size equals 0, size is less than there we go, integral type of size I equals 0, I less than size I plus plus. Okay, so we have a bool as this prefix equals false. Okay, so if let's see, if v1 of I let's say greater than v2 of I, then I want to do two things. Okay, we'll assume that it is true. true, then we'll say its prefix equals false, and we break. Okay. SV1 prefix of v2, we say is prefix ooh, my bad, and L. Size, I didn't do that. Okay. 1. Okay, so it's true. Okay, prefix. I can go, if it is true, then we can write true. Else we can write false. We have to put it in a bracket. Okay. Okay, let's say if I okay, that's enough for today.